It's his mom's name. Come on. That's important.
My name is Sheldon Williamson. I'm a professor and Canada Research Chair in the area of electric energy storage systems for transportation electrification. We do electric energy storage systems for transportation electrification. This lab that you see around here is the only lab that does this all across Canada. If you buy today a new electric vehicle, any brand, the inherent problem of lithium batteries is that they fade in capacity. It's anxiety range, and that's what's really blocking commercialization of electric transportation. What we have done in our lab is build novel battery management systems, so what we call or term as BMS. You will see battery management systems like this that sit on top of the battery pack. We can estimate the capacity fade, and that's the holy grail of designing an optimized battery management system. Let's say you have a 300-kilometer range car. Electric vehicles on an average can go about 350 kilometers at best, with the best technology out there today. If you add an optimized battery management system, something that we built today, we can give you about 600 kilometers range for an additional cost of, let's say, 1 or 2%. We are working with OEMs, so we have our partners here, right here in Toronto, with whom we are working with battery management system industry to actually optimize this and make it a cost-effective product so that it's a marketable product and market-ready. So I would say within another 3 to 4 years, we would have this in the market, and you'll see ranges of electric vehicles go upwards of 600 kilometers for the same cost. We'll shift our focus from the actual storage to the charging infrastructure, levels 2 and 3 of fast charging, conveniently or on the go, autonomous. So you don't have to bother about plugging in anymore. So this part would go in the ground, and this would be on the vehicle, so to speak. So if the vehicle comes and charges or stops over the secondary winding, you can pick up charge. 75 years down the line, where everyone is driverless, cars would be charging each other. One car battery would be charging another car battery, right? Neighboring battery transactions are happening. While you're the owner of the vehicle, you're the owner of the car. But how is that facilitated? Again, wireless power transfer. You have to charge these things from a distance. We've tested for different scenarios. This is inductive charging, and this goes way back to Tesla's patent in the late 1800s. And so he had a US patent or the first real patent to show that power could be transferred wirelessly. We actually have a Tesla coil in the lab. It was donated to us by a philanthropist by the name of Mary Mogford. She's a local donor, and she thought that it would be really inspirational for students to actually garner the knowledge from the first ever Tesla coil to do stuff like this, right? My love for research is going to actually keep me as an academic for some time. Students like you see around PhD students, they have a lot of impact on the society because their research feeds in directly to products with our industry partners. And that industry hires our students even before they graduate. So that is something that we take great pride in. Not all students can say that they can be hired before they even graduate. This is a universal charger. It's a plugged version of a DC charger, so you can actually take this on board, but now you're making everything compact and you can charge any battery voltage level. So we can actually take the same charger, go to China, versus take the same charger, come to Canada or the US and still use it to charge an electric vehicle specified for that country. It's like the reset button has been hit already with the big announcement by GM saying they're going to close all operations right here in Oshawa, down the road from us. And so it's a challenge. It's adversity, definitely, for the city, for the culture, for the history of Canadian automotive industry. But with that adversity also comes opportunity. I am absolutely sure we can actually, from ground zero, start to build an electric vehicle. Within the next 2 to 3 years, we can have the first version of the electric vehicle, a Canadian made and one of the best. So we have the technology, we have the skill set, we have the workforce who are very highly qualified personnel to do this kind of stuff. So I have no doubt the next 5 to 10 years are exciting times in Canada. my advice always to my grad students is always keep it simple. Don't complicate things too much, and that's what electrified transportation should be like. Is simplicity in its process, but keeping it simple takes a lot of effort in the background, and it's true for anything in life, right? You want to keep it simple, but that's what people see. What you do it's special to you. So these kids here, or these students, are one of a kind in the world. They know what they're doing, and they try to keep it simple. So that's what probably brings us more attention on a global scale, and that makes, as I said, new friends.
That's
Okay.
Did you have your